Hello everyone. Today I am going to explain about Rabin karp algorithm, which we can see is a powerful technique to search a string in a pattern. Okay, then let's see what is Rabin karp algorithm. As you can see, Rabin karp algorithm is a string searching algorithm created by Richard M. and Michael O. Rabin in 1987 that using hashing to find an exact match of a pattern string in a text. And let's see what is exactly Rabin karp doing. Given a text T of size n and a pattern P of size m, write a function search and we pass the pattern and text as an arguments that prints all the occurrence that present in the pattern that present in the text. And using Rabin karp, you may assume that length of the text is always greater than length of the pattern. Now let's see the algorithm of Rabin search or pattern. Now P is the pattern to look for and T is the text to look in. And T hash and TP are the hash functions. We will see the functions. And now N is the length of the text and K is the length of the pattern. Okay, now then here we are taking the hash value of text of first substring of length K, which is patterns, and we are considering pattern hash value. If the text hash value and the pattern hash value both are equal, then we will check whether the given numbers or then we will check the every character in the pattern that is equal to in the text or not. If it is not, then it will break the for loop if loop and then it will stop. Now let's see how it works. If the hash values are equal, the checking the hash values of pattern and substring of the text, if they are equal, then we will check the character step by step and let's see how it's done. Let's consider this as the string and this is the pattern we are searching for. If the hash values are equal, then we will search them by character by character. Here we can see A and D are not equal, so we will move one step forward. And here we can see the first character is itself goes wrong, and then next here it is the third one, and then next here it goes in the first and likewise, and we found the pattern in the string. Okay, now what happens now? We will see how this works. This is the code for C language and this is the hash function. It will take the parameter string starting integer end and we will take a prime number. This is the for loop and this simple mathematical function. We can change it, but according to Rabin karp, this is the algorithm. This is the function we should use, and it will return hash value. Now let's see the Rabin karp search pattern, and it will take parameters text and the pattern. As we saw in the algorithm, it taking the length of the text and length of the pattern, and we will take a prime number for changing its hash value, and the pattern hash value of the pattern, hash value of the text of first substring. Now here we are going to in a loop if the pattern's hash values are equal. As we saw in the diagrams, we will check the characters of the pattern and the text one by one, and if they are equal, then we will print that pattern is found at a index I. And now we won't stop the program. What if there is another pattern present in the text furthermore in the text? And now if we see here, and we will change the hash value. Okay, This and just we are changing the hash value here, and it is the main program. Here we are just taking the input from external storage. It's a piece of cake, nothing. Yeah, here we are calling the function in the main function, and then everything is about CSV file. We can also see the program in C++ language. The same thing goes here. It's the hash function and returns this, and same function just written another language, nothing more. Everything is same. uh, and now the Python, as we know Python, here also everything goes same, and then okay, right. Now let's see the time complexity of Rabin graph algorithm. The time complexity analysis of Rabin graph algorithm involves understanding the operations performed at each step and how they contribute to the overall runtime. We are discussing the hash time, calculating the hash value. The computing hash value of the pattern takes O of n time, where m is the length of the pattern, and calculating the hash value for the substring of the text, which is of the size m. And next, sliding pattern. Literally through the text, the sliding pattern takes O of n minus m plus 1, where the n is length of the pattern and m is the text. We will see. Here is a pen. Okay, there is no pen available. Now comparing the hash strings. If the hash search patterns, now updating the hash value. Updating the hash value takes O of n, and considering the above steps, the time complexity of the Rabin graph algorithm as approximated as in the worst case it would take O of n minus m plus 1 into n for complete pattern matching for all substrings in the text. This arises when the substring have the same hash value as we seen in the example in the previous slides. There's a necessity character by character verification. Yes, it will take the worst case, and worst case complexity occurs when such spurious hits occurs a number of all windows. This means checking every character by character in the pattern. And now average case is O of n plus 1, when the rolling hash function efficiently reduces the number of characters comparison required. And as you can see, the best case is O of n plus 1. Thank you.